All right. Let's get started with the next problem in this review. We had left off doing an equilibrium expression problem, so the next one reads, how many moles of gas does it take to occupy 120 liters at a pressure of 2.3 atmospheres and a temperature of 340 Kelvin? So this problem is a great example of you having to figure out what equation you need to solve it, okay? So without telling you, this is chapter 7 or 8 material or chapter 9. Let's look at what variables the problem gives us. If you read a problem like this and you have no idea where to begin, the best thing to do is label the variables you're given in your problem and then see what equation that fits, okay? So the question is asking for how many moles, okay? Moles of gas. And it also gives us another number with a unit here, 120 liters. That is a volume. It gives us a pressure, 2.3 atmospheres. So there's pressure. And it gives us a temperature. There's temperature. Moles is abbreviated with the number of moles in when we think about the equation PV equals nRT. Okay, and if you realize that you're given a volume, a pressure, and a temperature, it's asking you for N, and you always know R. R is a constant, okay? I would write this on your note card or have it memorized. So you know 1, 2, 3, 4 of these variables, and you are looking for N. So the equation you need to use is PV equals nRT. And hopefully you would recognize that by going through kind of like what we did in labeling what variables you're given. You're only given one pressure, one temperature, one volume. You're not given multiple pressures or multiple temperatures or volumes, so you're not going to use the combined gas law, okay? And plus the difference between PV equals nRT and the combined gas law is that you are either solving for moles up here or you're given a number of moles. In the combined gas law, you don't have a variable for number of moles. It's just volume, pressure, and temperature. So we're going to use PV equals nRT. The first thing I'm going to do is rearrange my equation because I want N by itself. So if I do that, the way to do that is divide both sides by R, variables R and T, and then they cancel out over here. So what we're left with, let's come over here, N equals PV over RT. So this is the form of the equation that we're going to use. Now we just plug everything in. The only thing we have to make sure of before we do that is that the units given for volume, pressure, and temperature match the units in R. So we need to know what R is. R is 0.0821, and that is liters times ATM divided by moles times Kelvin. Okay. So if you look at the volume up here, we are given liters, that matches. If you look at the units of pressure, atmospheres, that matches. And we have Kelvin in our temperature, so that matches. So everything matches the units in R. If, for example, we were given milliliters instead of liters, you would have to convert that to liters. If you were given like units of PSI instead of ATM, you would have to convert that to ATM before you could plug it into this equation. The units have to match what is given in the variable R, okay? But we don't have to do any of these conversions because we are already given the correct units, okay? So now we really will just plug everything in. N equals pressure, which is 2.3 ATM, atmospheres, times volume, which is 120 liters. And then R is 0.0821. Do write in all the units. Don't get lazy here. Liters times ATM over moles times Kelvin. And then all that, put that in brackets if you want, times the temperature, 340 Kelvin. Notice that ATM cancels, we have it on top and bottom. Liters cancel, have it on top and bottom. Kelvin cancels, it is already on bottom, and then we have it in another denominator on the bottom, so those cancel. What you're left with is units of 1 over 1 over mole, which in math world is just equal to moles. Okay, so the units will work out, and now we just punch this into our calculator. So you do 2.3 times 120. In the top here, we get 276 divided by 0.0821 times 340 divided by 27.914. I did my numerator all together, then I multiplied the numbers in my denominator, and now I'm going to do one more math problem here. 276, the top, divided by 27.914, and you should get 9.8, if I'm rounding, 9.89 moles. Okay, so that is the number of moles here for this problem. Okay, next problem. This one says hydrochloric acid, HCl, reacts with sodium hydroxide to form sodium chloride and water. If delta H is negative, there's a negative right here, 56.13 kilojoules per mole, and delta S is 79.11 joules per mole Kelvin, what is delta G for this reaction at 20 degrees Celsius? Okay, so this is a delta G problem. We're calculating delta G. So what is the equation for delta G? We'll write that out. Delta G equals delta H minus T delta S. So we're given the temperature over here at the end. Remember, the first thing we have to do is convert temperature to Kelvin if it's not already in Kelvin, and here it's not. So 20 degrees Celsius plus 273.15 is going to give us 293.15 Kelvin. This is the temperature we will plug into our delta G equation. The second thing we have to do is look at the units on delta H and look at the units on delta S. We got to make them match. So I like to take delta S and convert joules to kilojoules. So we're going to take delta S and we're going to convert joules to kilojoules, or it could be calories to kilocalories. You just have to make sure if you're given calories or joules, and in your delta H you have kilocalories or kilojoules, you've got to make those units match. So our delta S is 79.11 joules per mole times Kelvin, and we are going to convert that to kilojoules, so 1,000 joules for 1 kilojoule. So we should get 0.07911 kilojoules per mole Kelvin. Joules cancel out. We're left with kilojoules per mole Kelvin. Okay, so now we have done all that we need to do on the front end. Now we can use our delta G equation. So we come down here, we say delta G equals delta H, which is, don't forget there was a negative. So negative 56.13. Write all the units, please, kilojoules per mole. Minus, and I put this in brackets, temperature times delta S. So temperature is 293.15 Kelvin. And we're going to multiply that by our delta S, which is 0.07911 kilojoules per mole Kelvin. And close the brackets. So if you notice units of Kelvin, we have it on top and on bottom right here. So we're multiplying, those will cancel out. I'm going to do the math inside the brackets first. Multiply temperature, 293.15 times delta S, which is 0.07911 7911. And we get, there's the negative out front here, negative 23.19. And the units are kilojoules per mole. We also still have delta H, which is negative 56.13 kilojoules per mole. So it's just negative 56.13 minus 23.19. So we'll say negative 56.13 minus 23.19. You should get that delta G equals negative 79.32 kilojoules per mole. And that looks like it matches answer A. Close enough. Off by 0.01. But that is how we solve for delta G here. Okay, moving on to the next problem.